Okay, let's look at problem 2. Graph the functions below. Be sure to include at least 3 points for each function. Graph and label both functions on the same grid. So f of x equals 5 to the power of x. So let's think about our key points. Our first key point would be our x value of 0. If x is 0, then we'll have 5 to the power of 0 is 1. And so I get my first point right there. If I then did an x value of 1, well, I get a y value of 5, the value of the base. So I'll put my next point right there. I'll label that as 1, 5. I'll label that first one as 0, 1. Remember, that's our key point that we move around. And then let's do another point. Options here, depending on your preference. You could either show this point up here, which would be 2, 25. Or you could show the fraction-y point and do -1, 1/5. Either's fine. That point would be shown like that. Either's fine, and then we can kind of draw that in. Remember, it has a horizontal asymptote, so it's going to look something like that. Horizontal asymptote at 0. All right, well, on the same axes, we now want to graph its inverse, log base 5 of x. And you really don't need to know how to graph log function to do this. You just need to understand that, I'm going to move that, you just need to understand that if you're graphing a log, you're graphing the inverse of an exponential. And if we just graph this exponential and now we want to graph the log, all I need to do is swap the coordinates. So instead of 0, 1, I'm going to have 1, 0. I'll label that 1, 0. Instead of 1, 5, we're going to have 5, 1. So we'll call that 5, 1. And then instead of 2, 25, we're going to have 25, 2. So maybe about there. 25, 2. Similarly, instead of -1, 1/5, I will have an x value of 1/5, a y value of -1. So that point would be like there. So 1/5, -1. So I'm showing 4 points, more than you need to show. So either choose the 25 point or choose the 1/5 point. Either's fine. Sketch it in. Remember, it has a vertical asymptote at x equals 0 because the exponential had a horizontal asymptote at y equals 0. And what's the connection here? It is perfect symmetry across the line. Y equals x, and it should look like it is. So it's going to look something like that. There is our points. Now, B says use our results from A to sketch the graph of 4 times log base 5 of x plus 10 plus 5, which might sound scary at first, but all we need to do is use our pink graph. If we're using our pink graph, then we are going to just apply transformations to it. So the point that I would recommend you start with is our key point, that x-intercept right there, 1, 0. Let's figure out where that point moves. Well, that point, because of the x plus 10, we know that transformation, x plus 10, moves everything to the left 10. So if we're moving it to the left 10, then what's the new x value going to be? Well, it's starting at 1, and it's going left 10, so it's going to go to 9, -9. And what's the new y value going to be? Well, it was at 0, but we were adding 5, so my y value has to be 5. So I'll get my first point. It's going to be over here at -9, +5 right there. Let's label it -9, +5. Use tick marks if you like tick marks. Where is my vertical asymptote? Well, my vertical asymptote was at an x value of 0, but everything's moving left 10, so it is now at an x value of, let's move this, it's now at an x value of -10. So there's my asymptote right there at x equals -10. All right, and then there was that point. Okay, well, how do I do the other points? Well, what's nice is that all of these x distances between the points, so like that x distance right there, it's going to remain the same. So from 1, I went to 5, so I went over 4. So my next point is also going to go over 4. So if it's over 4 from -9, it's now at -5. But how far up is it going to be? Well, what was the y distance? The y distance there was 1, x distance was 4, y distance was 1. It was 1 above that other point. So now it's going to be 4 above that point because it's being stretched. So the point, generally speaking, is probably going to be somewhere around here. Get it in the best spot you can if we're not using tick marks, but use tick marks if you like tick marks. Where's that going to be? Well, that's going to be at -5, comma, go up 5. So up 5 from 5 means we're at, I'm sorry, go up 4. Up 4 from 5 is 9. And so we get that point right there, -5, 9. It is 4 to the right, and it is 4 up. 4 to the right because that was 4 to the right. 4 up because we're stretching the 1 by 4. Alrighty, next point was at 25. So if you think about where that is from the last point we just did, well, that is now 20 over, right? That's 20 over, so this point is going to be 20 over. So instead of at -5, it's now going to be at +15. So we're like way over here. So that point is going to be +15. And what's the y value going to be? Well, again, notice this point was 1 up from the last one. So we're going to be 4 up from the last one. So 4 up from 9 means we are at 13. We have that point right there. Now I could do the same thing one more time if I wanted to work backwards and use that fraction point. That was at 1/5. You think of it as being 1/5 to the right of the asymptote. So our point here is going to be about right there. The x value is going to be 1/5 more than -10. So that x value is going to be -9 4/5 gross mixed number, comma, what's the y value? Well, that's got to be 4 down from that last point, so it's got to be at 1 right there. And now we can draw in our curve, and it's going to look something like that. And that is our transformed log. Again, let's hit the key points. The x distances between the points remain the same. The y values get stretched by that stretch factor, so instead of all of those points being 1 apart, y-wise, they're now 4 apart. And then the +10, +5, normal shift left and right like you are used to. And that should be our final graph. Use tick marks or label the points appropriately, whatever makes more sense to your brain.